This is Mr. Precella. Today I'm going to be working some problems reviewing my face-to-face trigonometry class for a test over simplifying identities. And again, this is my face-to-face trigonometry, not my online trigonometry class. And, this one I've already written down the answer. Let's see. Number 1. 1 over cosecant x minus cosecant x. Well, what could I do here? Well, let's try writing everything in terms of sine and cosine. That 1 over cosecant x, well, that would just be sine x, okay, because sine x is the reciprocal of cosecant x. Then minus, how would I rewrite cosecant in terms of sine? Well, that's pretty easy, 1 over sine x. I put that over 1 because I'm thinking, let's get a common denominator. Our common denominator here would just be a sine x. And on this one, if I'm going to get a sine x down here, that means I'm multiplying above and below by sine x. So we're going to have a sine squared x. So I've rewritten sine x as sine squared x over sine x minus, we already have this one written with a common denominator. So we have sine squared x minus 1. Now, let me find some scratch paper, because that top brings something to mind. It brings that first Pythagorean identity to mind when I seen sine squared x minus 1. So this is just my scratch paper. If I think sine squared x plus cosine squared x equals 1, I could move this around to get sine squared x minus 1. Let's see, what could I do? I could move the cosine squared x over there by subtracting. And I could subtract 1 to move the the 1 over. So we have sine squared x minus 1, which is that top part, equals negative cosine squared x. So this top here, sine squared x minus 1 is negative cosine squared x all over sine x. Now, I could think of that cosine squared x as negative cosine x times cosine x. And then, okay, cosine x over sine x would be cotangent x, negative cosine x, cotangent x. Negative cosine x, I changed color, over cosine over sine, cotangent x. I'm using someone's review sheet and it's already sort of marked up a little. This one already had the answer circled on it, but the rest of them I don't think will have the answer on it. That's a minus sign right there, in case you can't read it. So here's problem number 2. Let me write it down, color coding it. 2 cotangent x minus 1 plus cotangent x all squared. Well, this 1 plus cotangent x squared, we're going to have to FOIL that out. Some of you can do that in your head. Some of you need to write it out. Either way is okay. So just sort of FOILing it out, showing my thought process. We have a 1 plus 1 cotangent x plus 1 cotangent x. That's going to be a 2 cotangent x plus cotangent x times cotangent x, cotangent squared x. So we have 2 cotangent x minus all of this. Now we're going to need to distribute that orange minus sign. but alarm bells are going off in my head. Let's see, what's concerning me at this point? Well, when I look inside these parentheses, I notice a 1 plus cotangent squared x. A 1 plus cotangent squared x, that's one of those Pythagorean identities. I could replace 1 plus cotangent squared x with cosecant squared x. So let's see what would happen if I did that. So in these parentheses, instead of having 1 plus cotangent squared x, I'm going to write that as cosecant squared x. And I still have that plus 2 cotangent x. And now I need to distribute this minus. And let's see, what are we going to have? We'd have a 2 cotangent x minus cosecant squared x, and then a minus 2 cotangent x. Oh, hey, I think we got one of those answers, don't we? I thought to replace the 1 plus cotangent squared x with cosecant squared x, just because 2 of the answer choices involve a cosecant. Okay? And also, I have those Pythagorean identities memorized just like you should. When you see 1 plus cotangent squared x, your brain should be thinking cosecant squared x. Okay? So negative cosecant squared x, that is C. Just like this one over here was B. What about number 3? Is this one going to involve another cotangent x and a cosecant? It sure looks it. What I would do on this one is start out by expanding or foiling out the cotangent. Let me write it out. Cotangent x plus 1 times cotangent x plus 1. Then we have a minus cosecant squared x all over a pink cotangent x. Sort of color coding it as I go through. I'm going to FOIL out the cotangent x plus 1, just like I FOILed out the 1 plus cotangent x. It would be cotangent squared x plus 1 cotangent x plus 1 cotangent x. That's 2 cotangent x plus 1 minus cosecant squared x all over cotangent x. Oh, this one's going to simplify really nicely. Look at the answer choices. Either cotangent x, 2, 1, or 0. Well, once again, something's staring me in the face. It's that same identity we just used. It's the same Pythagorean identity. 1 plus cotangent squared x is cosecant squared x. So if I replace the cotangent squared x plus 1, ooh, let me move this up. Can y'all see that? I can replace cotangent squared x plus 1 with cosecant squared x. I still have this plus 2 cotangent x. And we have this minus cosecant squared x there. Oh, this is going to simplify really nicely. Notice the cosecant squared x minus cosecant squared x, those can't, or subtract out. And then 2 cotangent x over cotangent x. You can cancel the cotangent x's, and you're just left with the number 2. Okay. Sort of going through these quickly. This isn't a first time to work some of these identities, or to work with identities like this, is it? Ooh, wee. So we're up to number 4. 4. Sine squared x over 1 minus cotangent squared x. Yesterday a student asked me, could we use a Pythagorean identity on this? And, well, that sine squared x minus, not a plus, and the same thing right here, there's 1 minus cotangent squared x, not a plus cotangent squared x. Let's see. This one, there's a couple of ways, or no, really there's only one. Oops. That's a cotangent squared x, 1 minus cotangent squared x. I was going straight to what I was going to do first, was write everything in terms of sine and cosine. If I wrote everything in terms of sine and cosine, the thing that I need to rewrite is this cotangent. So it's going to look a little messy at first. Sine squared x minus cosine squared x over 1 minus, thinking of that cotangent as cosine squared x over sine squared x. If we look at our answer choice, it's going to equal one of those. Okay. First glance, you might think, well, heck, you made it look even worse, and, well, okay, you might be inclined to think that. But if we get rid of this, let's try to eliminate this denominator right here so that we don't have a fraction within a fraction. Well, to do that, we could multiply above and below by green sine squared x. If I multiply above and below by green sine squared x, it's going to all of a sudden simplify out really nice. On the top, let's hold off from distributing that sine squared x. If I distributed it, I'd wind up with a sine to the 4th x. That seems like we're just getting bigger exponents. It's either going to simplify to sine squared x, cosine squared x, 1 or negative 1. Let's just hold off on it. Don't distribute that sine squared x right now. If we leave it like this, now here, let's distribute the sine squared x. Y'all see what's about to happen? If I distribute the sine squared x here, I'd have sine squared x minus, what's happening here? Sine squared x times cosine squared x over sine squared x. Those sine squared x's are canceling, so we just have a cosine squared x. Now do you sort of see why I didn't distribute this sine squared here? What can I do now? Cancel? Yeah, I can cancel sine squared x minus cosine x over sine squared x minus cosine squared x. And all that's left there is just a sine squared x. So that would be A. Let's see, number 5. Sine x plus 1 times sine x minus 1. It's number 5. All over tangent squared x. Not sine, it's secant x plus 1 times secant x minus 1 all over tangent squared x. Look at how it's going to simplify. Either 1, negative 1, 2, or 0. We'll FOIL out the top. Let's see what we're going to get. Is secant x times secant x is secant squared x. This is a difference of squares, right? Minus 1 secant x plus 1 secant x. So when you do outer and inner, those are subtracting out. And a minus 1 all over tangent squared x. This is sure making me think of a Pythagorean identity. In particular, the 1 plus tangent squared x is secant squared x. Look at that. We could rewrite, okay, so this is just here's my scratch word. I think of 1 plus tangent squared x is secant squared x. That means that secant squared x minus 1 is tangent squared x. You'll see I could subtract 1 from both sides here, and that gets me an equivalent statement saying secant squared x minus 1 is tangent squared x. So we have a tangent squared x on the top and a tangent squared x on the bottom. That equals 1. So which one is that? D. Y'all caught up? Number 6 is a tricky little problem. You're either going to think it's easy or it's hard. Number 6. Tangent squared 5x plus cosine squared 5x plus sine squared 5x. Don't let the fact that there's 5x's here worry you. You work this the same way you would if this were just any angle theta, or, the significant thing is they're all the same angle measurement. Don't start adding the 5x plus 5x. Don't get a 10x or a 15x. So just treat it as if this were theta. And the thing that stands out in my head is cosine squared theta plus sine squared theta. That's 1. Here's the first Pythagorean identity. I think we even had a problem like this well, when I'm recording this video, my class did have a problem like this one on the first test. But it didn't have a 5x or anything. I think it was just theta. And now, if you replace that with 1, we have tangent squared 5x plus 1. Again, just treat the 5x as if it were theta. So 1 plus tangent squared theta is secant squared theta. But the theta is 5x. So tangent squared 5x plus cosine squared 5x plus sine squared 5x is secant squared 5x. About to say, there's a mistake. Sometimes they'll pop out somewhere there's not a correct answer. But then I saw this one. I hadn't seen it. Okay? And again, you do this the same way as if it had just been theta. There's nothing special about the 5x. It could be anything. They're just all the same angle. Cosine squared theta plus sine squared theta is 1. Tangent squared theta plus 1 is secant squared theta. But the theta is 5x. Do not start adding and get a 10x anywhere there. Problem number 7. 1 minus. Oh gosh. Oops. This one looks kind of tricky. 1 minus. Oh, let me lift this up. Can y'all see it? And then this fraction. Cosine squared x over 1 plus sine squared x. No, over 1 plus sine x. Now look at the answers that we're going to get. Either a 0 or a tangent x, which would probably, it's going to wind up with maybe sine x over cosine x, or sine x, or it might all simplify just to cosine x over sine x. So somehow or another, I'm going to need to simplify this a lot, and the way I'm going to go about this is simplifying this fraction first right here. The cosine squared x over 1 plus sine squared x. Well, I need to somehow, if I'm going to simplify this sum, I'm going to need to cancel some stuff. In particular, that 1 plus sine x is probably going to have to be canceled. So how could I go about that? Well, thinking of this first Pythagorean identity, cosine squared theta plus sine squared theta is 1, or in turn, I should say x. So here's just my little thoughts. It's scratch work right here. Sine squared x plus cosine squared x is 1. So cosine squared x could be replaced with 1 minus sine squared x. And now there's a lot of ways, not a lot of ways, but there's a couple of wrong ways to cancel this or to simplify this fraction. Before you start canceling, you need to factor. So we have a 1, then that blue minus, and above the green fraction. You don't just cancel the 1s and don't cancel the 1 and the sine x. You've got to factor that top first. You can only cancel factors. So 1 minus sine squared x, you could factor as a difference of squares. 1 minus sine x times 1 plus sine x. This is the correct way to cancel, or to simplify that. You can't just cancel the 1s and the sine x's. Sometimes people do that, and they might still get the right answer, but realize you're actually doing it wrong. 1 minus we still have this parentheses 1 minus sine x. So it looks like we can distribute this minus here. So we have the orange 1, then minus 1, so those 1s are gone, and then plus sine x. So all we have left there is sine x, so that's B. What about number 8? Well, let's see. Problem number 8. So already in terms of sine and cosine, there's no squares in it, but there's just one term down here in the bottom. So this one's actually going to be the easiest one we've done so far. Since there's just one term down here, you could just separate it. Write it as 1 over sine x minus cosine x over sine x. What you're actually doing is using the definition of subtraction of fractions with a common denominator. Since they have a common denominator, that means each one of these, you could write it as 2 separate fractions with that common denominator. And now heck, 1 over sine x is cosecant x. Cosine x over sine x is cotangent x. So that is B. Now, we're about to start using some sum and difference identities here. So let's just remember the sum and difference identities. For sine A plus or minus B. To expand this, you don't just distribute the SIN. There's a pattern. Do y'all remember? It's sine, cosine, same symbol, cosine, sine. Sine, cosine, cosine, sine, same symbol in the middle. The word same begins with S, just like sine. So you got to remember those patterns. For cosine A plus or minus B, it's cosine cosine, change, sine, sine. And again, this isn't the first time we've worked with identities. You've seen me write them out like this before, and you should be familiar with what I mean by this, the way I've changed the plus minus to a minus plus. If there were a plus in it, then you change it to a minus. If there's a minus, you change it to a plus. That symbol in the middle, you change it. Remember that because cosine begins with the letter C, just like change. So for sine A plus or minus B, sine, cosine, cosine, sine, same symbol in the middle. Notice I'm always going first angle, second angle, first angle, second angle. For cosine, the pattern is cosine, cosine, sine, sine, change the symbol in the middle. Notice I'm going A, B, A, B, first angle, second angle. For tangent, A plus or minus B, it's tangent A, same symbol, tangent B, over 1, change the symbol, tangent A times tangent B. And you can remember same symbol and change the symbol based on the fact that tangent is sine over cosine. So same symbol here, change the symbol there. Same, change. Somehow or another you need to have those memorized. So let's see, problem number 9. Sine x plus pi over 2. Let's see. Sine x plus pi over 2. Well, sine, cosine, same symbol, cosine, sine. Sine, cosine, cosine, sine, same symbol in the middle. Notice here I'm going first angle, second, first, second. Now pi over 2, can y'all see that unit circle in your head? Pi over 2 would be right there, 90 degrees. And that point of intersection is over 0, up 1. Remember these, on the unit circle, the points of intersection are in the order cosine, sine. So the cosine of pi over 2 is 0. The sine of pi over 2 is 1. So sine x times 0 is 0. Cosine x times 1 is just cosine x. So it is A. Oh no! Look at this number 10. It really looks messy, doesn't it? So problem number 10. I better color code this. Cosine alpha plus beta. The beta looks like a B. Plus. So this plus here is that plus there. Cosine alpha minus beta. So let's see. I'm going to expand this one. It's cosine, cosine, change, sine, sine. Cosine, cosine, sine, sine, change the symbol in the middle. You're probably sick of hearing me say that. Cosine alpha minus beta, that's cosine, cosine, change, sine, sine. Cosine, cosine, change, sine, sine. Let's see. Oh, this is going to fall out really nicely. The sine alpha, negative sine alpha sine beta, and plus sine alpha sine beta, those subtract out. So you have cosine alpha cosine beta plus cosine alpha cosine beta. That's just going to be 2 cosine alpha cosine beta. Let me see, 2. Oh, look closely. B and C look the same, don't they? But it is B. Number 11. Do I have time to do number 11? Let me see. I guess so. Cosine alpha plus beta divided by cosine alpha cosine beta. Okay. Let me see. I'm running out of paper on that. Here. Use this paper. Well, let's start off by expanding sine alpha plus beta. If I expand sine alpha plus beta. So I'm going to expand sine alpha plus beta. I'll do that in brackets. Sine, cosine, same symbol, cosine, sine. And this is another one where there's only, my blue pen is running out of ink. Where there's just one term in the bottom. There's no addition and subtraction. So we can separate it again. That one we did earlier. Sine alpha cosine beta over cosine alpha cosine beta, so notice that. Then plus cosine alpha sine beta over cosine alpha cosine beta. So I'm putting each one of these over cosine alpha cosine beta. So we have sine alpha over cosine alpha, that's tangent alpha, plus sine beta over cosine beta is tangent beta. So that is, let's see, which one is number 11? Is it B? B and C sure look alike. In fact, they are, aren't they? Look at that. That sometimes happens, doesn't it? Okay. It could have been B or C because addition is commutative, right? So tangent beta plus alpha is the same thing as tangent alpha plus beta. So I think we'll take a break right now, and we still have 9 more left to go, so I'll do that later. So thanks for watching. I'm taking a break right now. Again, this is Anthony Precella reviewing some trigonometry for my face-to-face class for a test over simplifying identities. Thank you.